This data set is taken from Professor Naikan's book, and as you see, 25 samples have been tested, but compared to what we had before, these are not presented in intervals of time, and also the time to failure are not uniformly spaced, and sometimes more than one failure has been observed. So it's different in that sense from the earlier data that we analyzed from Schumann's book. So this problem will actually be part of the homework set as well. So I would like you to compute the reliability function, the density function of the time to failure, and the hazard function, and also estimate the mean time to failure. So we have the formulas. You can carefully fill up all these cells in the table. If you would like to do it yourself now, please pause the video. Otherwise, I will present the solutions. So here it is. So we have I have filled up. So the third column is the number of surviving elements, all the way from time 0 hours to 88 hours, and then the reliability function, which is the ratio of the fraction of the surviving elements. So that's straightforward. And then the density function, it's evaluated, so two times are involved when we compute the differences. So if you look carefully at the very first row under the density function, the 4 is the number of units that have failed between time 0 and time 9 hours. 25 is the N0, the original number of samples, and 9 is the length of the interval, 9 hours. So that's how we continue all the way up to 68, because we can't go beyond that, and that's where the density function is 0.002 per hour. In the last column, we have the hazard function, and again the first number there, that 4 is the number of failures that happened in the interval 0 to 9, and then 25 is the number of elements that we started with, that interval, which is N0 in this particular interval, and 9 is the length of the interval. So that gives us 0.0177 per hour. Going down, the second value of the hazard function corresponding to 9 hours, so that the first number 1 is the number of failures that happened. The second number 21 is the number of surviving elements that we started with, so that is NTI, and then the last number 2 is the duration of the interval, which is 2 hours. So that gives us 0.0238 per hour. This way we can fill up all the cells and obtain an estimate of the hazard function. What I haven't done, and you need to do for your homework problem, is to estimate the mean time to failure from this data set.